Welcome back to DemystifySci. I'm Shiloh.
I'm Anastasia.
We are broadcasting the sweatiest version of the DemystifySci podcast that we've ever done today. We're here in the jungle on some island in the middle of the Pacific. It's very beautiful but sweaty, and the mosquitoes are devouring us, and the chickens are running around, and we hope that won't distract you too much, because today we are talking about, we're continuing our conversation about the border between mysticism and science.
But it is anchored to a very specific fact. So we have gotten in touch with Terrence Howard, and next week...
Who's Terrence Howard?
So Terrence Howard was this physics mystic who ended up on the Joe Rogan podcast because he's developed an alternative view of basically every single piece of physics.
What's the Joe Rogan podcast?
I don't know. Somebody mentioned
it's
that he was
big or
on
something.
there. I think so.
Yeah, he's got a big audience, I guess. A lot of attention on this guy and his physics ideas is what happened. And one of our friends through the podcast since the very first day is Chris, put us in touch with Terrence and told Terrence about us. Terrence actually listened to some of our podcasts already before then. And he was like, all right, I want you guys to challenge me. I want you guys to bring the hard criticism of my work to the table. And we said, all right, let's do it. And he said, I can't do this over Zoom. You got to come down to LA and do it in person. So we said, all right, challenge accepted. Now, a lot of Terrence's ideas and his language seems to come from a pedigree that dates back through one of the early mystics, scientific mystics, a guy named Walter Russel. And so I read part of Walter Russell's formative text. It's called The Universal One. You should check it out if you want. And I pulled some quotes because what I'm trying to highlight here is how the mystics, in some sense, like Walter Russell, have been able to see something about the nature of reality, in this case physical reality, that the future uncovers much later. And that's not to say that Walter Russell nailed it with every sentence in the book. It is impenetrable poetry at some points. It sounds like a deep psychedelic trip at other points. But there's something there, too. And I hope that when we go and scrutinize Terrence's work, that we're able to find the something there's where they exist, and maybe use them to fill in some of the gaps in our understanding where standard theory has run up against a wall.
So it's going to be an adventure to go and see if we can figure all of this out, but I think that we're up for it. And so if you like what we do and you want to support the podcast, consider coming over to patreon.com. We're currently exclusively supported by our patrons, which means that we're free to make the podcast on the topics that we're all interested in. We don't have sponsors. We don't have advertisers. It is just a direct relationship between us and you guys. So come on over to patreon.com/DemystifySci and join us if you have the spare cash.
I mean, it's also a really special Patreon experience. From what I can tell, this isn't just come over and give us cash. We get together all as a group once a week and chop it up about all these topics and more, and really try to inform one another about where cool stuff's happening in these intellectual ideas spaces. So it's actually a really cool internal community, and for whatever reason, we've collected some really amazing people who all have very different life experiences and different ways of approaching these questions. So come inside the community. And in doing that, you can make sure that we're able to put more and more time to this project.
Indeed.
And we don't have to sell you stuff.
That's absolutely true. And if you don't have any cash that you can donate to us right now, that's totally fine. You can leave a comment, you can like, subscribe, you can come over to our Discord. We have a Facebook group, we're on Twitter. There's every single place that you can search for us. We are there. Tell your friends about the DemystifySci podcast.
Tell your mom.
Indeed, moms love us. And so in the meantime, enjoy our conversation about mysticism, science, and searching for the needle in the hay. We'll see you next time.
The scientific revolution starts now.
The DemystifySci podcast.
Let us see in the dark.
So we're going to Los Angeles. And we have perhaps one of the most difficult conversations that we have ever had on this show on our plate, which is that we have to decipher Terrence Howard's ideas. And Terrence Howard is, I'd say, closer to a mystic than a physicist.
Mathematical mystic, perhaps?
Mathematical mystic. I think that's really good. And I think he has some interesting pieces to the work that he's been doing, which is demonstrated simply in the fact that he's building technology with it. Like, he's got ideas that he's able to put together into these geometric structures, and then the geometric structures allow you to do stuff. And so we're trying to thread the needle of, okay, well, what parts of the ideas that then inform the design are actually scientifically viable and scientifically relevant?
Yeah, that's the trick. Because in some sense, science and technology have been completely intertwined in our civilization. And most people couldn't tell you the difference, even people who work inside the academy. But we clearly have two different schools, one of science and one of technology. And so most people work somewhere in between, right? Both of our labs, last time we worked in labs, were involved in technology and were...
Yeah, that's true. One of my labs was.
Dabbling in science, right? I don't know.
Yeah.
Were the electrical engineering guys dabbling in science? A little bit, right? Brain mapping or something.
Yeah. It was more like brain control. Like,
Yeah.
they were very, very... I mean, it was an engineering lab. It was the bioengineering lab. It wasn't like a...
My lab was mostly engineering, but it was a science lab. So my point is that most people, if you look historically, dabble in both. It's hard to be an inventor and not pay attention to nature, and therefore not come up with some sort of map of how nature works.
You spend a lot of time thinking about it, and even if it's not necessarily the papers that you're writing or whatever, you do end up in a position where you're like, hey, you know, it's really interesting. I've been thinking a lot about this, and I have this idea about the universe. And so with Terrence Howard, I think the trickiest part is that, like all mystics, I don't know if you guys can hear the chickens. So it turns out that somebody introduced chickens to this island a long time ago, and now there's just, they occupy the same niche as pigeons, which I really appreciate. They're much more beautiful than pigeons. Pigeons just always seem really depressing to me. But there's just a straight up beautiful rooster.
The roosters look more or less the same, but the hens look extremely wild.
They're just so delicately filigreed. Oh, he's coming over. Come say
He's interested.
hi.
All right, we might have a rooster join us in a second. But
so the tricky thing with Terrence is that he's so mystical. Like, he has this innate realization about the organization of the cosmos.
I think that he also starts from a very valid criticism of standard physics, which is that it's mathematical at the expense of being physical, right? So this crux moment, of course, occurred about 100 years ago when all the best physicists got together at the Solvay Conference, 5th Solvay Conference. 3/4 of them went on to win Nobel Prizes. And they decided that reality didn't have to make sense anymore. And
specifically, they decided that it was okay to have a mathematical, probabilistic model of reality rather than trying to figure out what were the actual building blocks of nature.
I actually think it was more radical than that.
Really?
Because of the wave-particle duality, which they accepted as being a fact of the matter, as opposed to trying to understand why it was that it sometimes appeared that these events were treated as particles and sometimes they appeared as waves. They actually just decided it would be a wavesicle all of a sudden, or a wavicle, or something like that. So there's this moment where things fracture, and of course the failure of the various ether detection experiments fed into this. The advent of quantum mechanics fed into this. But there's a moment where we abandon the mediators. And of course the field gets created, and for most people, especially students, people I interacted with in the academy, the field feels sufficiently material that people go along with it, because it feels like a medium. And it isn't until you start to poke at it a little bit that you realize, wait a second, this is just a sea of measurements. This is a sea of vectors, a sea of predicted outputs to however we'll probe it. And so it's a map without any territory. And so Terence comes at this primarily from the standpoint that modern physics doesn't have a mediator. Therefore, it doesn't really have an explanation for light, gravity, electricity, and magnetism. And this is actually something that we are firmly on board with.
Sure.
And interested in.
And I think that as part of this project, we've talked to other people that have I don't want to say that they have solutions to this problem, but I think that the transactional interpretation folks, the Ruth Kastner, the John Kramer, the Carver Meads of the world, they're basically looking at this and they're like, hey, there is no mediator, and so we need to recast this as communication between atoms. But they don't necessarily have a solution to what that communication is. They just recognize that they must be in communication.
I would say they propose a solution, but it's just as mystical as anything Terence is offering.
Which is the like reverse time thing.
Exactly. So they say, wait a second, both these atoms are involved. They're separated at some distance. And I'm really worried this chicken's going to come up on me in a second.
No, it's
God,
okay.
that's a beautiful chicken. I wish we could show
gorgeous.
people. Maybe we'll get a little pan here in a second. Actually, can we do it real quick? You guys want to see this crazy rooster? Look at that thing. I don't know if you can see that. So the thing that they're proposing is they look at the atomic landscape. They're like, I think that it makes sense that the atoms are coming into some resonant equilibrium with each other. How in the world can two separate atoms do that? Well, one must be reaching backwards in time. And it's a completely mathematically transparent argument because in math, space and time are completely inseparable. That is I would say, one of the biggest impediments to progress in modern physics from the outside that I can see. They can't tell the difference between time and space.
Can you diagnose how that's possible? Like, I don't totally... I mean, I recognize that it is so, but I don't totally understand why it is
How it happens?
Yeah, how did that happen?
I mean, people might have other ideas in the comments. I'd love to hear them. But for me, I think it comes down to the speed of light being the measuring stick for astronomical events. And if you've noticed, one of the weirdest things when you're a kid, when somebody says that star is blank far away, they'll say light years. And the first thing you think as a kid is, how the hell, what? You're measuring stuff in years? Like, if somebody's like, you have to walk a mile to school, they're not like, you have to walk a foot minute. 15 minutes to school or something, right? But you can see how vectors that have a speed and an angle can be transmitted very easily into distance, right? So that's the first derivative of speed, of velocity. So because the speed of light is constant, you can translate it into distance, assuming nothing weird happens, and that's where things often go off the rails. But because of that, people got really comfortable, I think, with treating distance and time as synonymous because the main yardstick is the speed of light.
But that's still so weird to me because I'm like, it might be the main yardstick, but still we're talking about two different ways of measuring the same interval.
It was really fun to check that idea with these physicists and to be like, wait a second, couldn't this transaction be occurring across space? And of course, across space. And then they're like, well, that can't be possible. How could atoms reach each other? And then you're like, well, have you heard of the probability distribution function for the electron? Isn't the electron the outer surface of the atom? Couldn't these atoms actually be touching each other even though it's only a rarefied portion of the atom? And they're kind of like, yeah. So that's what makes that idea really interesting to us. Mathematically, bringing two atoms into equilibrium makes a ton of sense. Light being the transaction by which that happens. Sort of like how sound would do it if I walked into a guitar shop and I started playing a trumpet at some note. I'd probably get some of the guitar strings to sing with me because the sound waves would serve as the mediator, or the air would serve as the medium, and the sound waves would mediate the resonant transfers so that they would be brought into some resonant equilibrium. And so the idea that something's happening with light, similarly, is way more attractive than these magic bullet balls being shot off into space that just happen to juice up atoms. And we know that the atoms aren't just these electron bowling balls flying around a nucleus. Nobody actually thinks that, but nobody really has a better idea at the same time. So Terrence's motivation comes from this same realization, as far as I can tell. The schematic diagrams, the Bohr atom, the cloud atom, they don't have sufficient mechanical basis to be intuitively understood. What's worse is that over the last 100 years, the physicists have decided that things don't have to intuitively make sense, and really get out of here if you're interested in that. You have to abandon your intuition. I mean, there's quote after quote after quote of famous physicists saying, this doesn't have to make sense. You have to stop trying to... Look, my physics teachers told me that when I was in college. So we all, not all of us, but a lot of people, I'm sure you guys who are listening to this have had this alienating moment at one point or another. And that's why you've probably found this podcast, where somebody told you something didn't have to make sense, and that was okay. Here's how you calculate the answer so you can pass the test.
And it's really interesting to me that a lot of the criticism of mainstream physics has been occupied by the mystics. Have you noticed this?
No.
Where, like, the...
Indeed.
I'm thinking specifically of, is it Nassim Haramein?
Haven't listened to a ton of him.
I haven't listened to a ton of him, but it's very kind of like quantum woo, spooky. Things are inexplicable and strange and mystical. And they're very, as far as I can tell, he's very critical of mainstream physics. And I guess I've been, a lot of the kind of alchemical YouTube channels that I've seen, like there's this really, really strong desire to be able to return to the ether. And with that desire, I've seen kind of almost ideologically medieval presentations where it's this idea that, you know, all of modern physics is totally wrong. It's the ether, and if you have the ether, you resolve everything and you can turn lead into gold. There's a lot of stuff about resonance and harmonics and fractals, and it's like all of these things that are, I would say, like almost quasi-numerology. Like I watched who's the guy with the explosion just before the end of the last ice age, the guy who works with Graham Hancock.
Randall Carlson.
I watched a presentation that he gave on the oddity of the moon, and the underpinning of the presentation was that like our story of the moon wasn't accurate, and he had some interesting geological points. But before that, he did all of this numerology where he's like the diameter of the moon and the time of the Earth's 25,000-year precessional orbit is divisible into each other. And it was just very interesting to me where it's like there's not a real meaning there. It's just this number relationship that seems to really entrance people. And I find that to be the case in a lot of this ether science that is the common antithesis to mainstream physics.
I think the pattern finding is at the heart of science. And it's the very first place where a theory begins, is noticing a pattern, whether it's a hereditary pattern and you start to think about how that could happen, or it's a pattern in the sky with some stars and they're related in some way, or the pattern of the way a star dims and brightens. You first notice something that is persistent, consistent, and you can show it to other people and they can say, okay, yeah, that is something happening. It seems to be a part of universal behavior. Now, how do we explain it? And so it's really easy to look at just to look at quantities and find patterns.
Sure.
That's essentially what math is it's a pattern organizing utensil that you set up patterns, and operations in some sense are patterned processes that you process your numbers with. So I think it's really easy to start seeing patterns in numbers, more so than almost anything else. I mean, obviously people see faces and tree stumps and there's this kind of thing, but I think math and quantity more than anything is open to that. And people have a deep sense that the cosmic is A, simple, and B, beautiful in a symmetric sort of way. And so they're dying for nature to conform to their idea of beauty being this simple, symmetric process.
And that's the case, I think, on the mystical side and on the conventional physics side.
Exactly.
They come at it from different perspectives. But I think that, the search for supersymmetric theories is no different, really, than somebody being obsessed with the idea that there's a fractal organization of the universe.
Because wouldn't it be great? I mean, the reason people want those supersymmetric theories, like I was telling you earlier, is because they want to have general relativity fall out of the standard model. Wouldn't that be nice? It would be so nice. We could just have one theory. It would be very simple. We wouldn't have to have these situational theories. How great. But the reality is, coming from like a really mundane physics background myself, where we're just doing material science, every single material under various different pressure regimes and so forth has completely different properties and different equations that govern it.
Different equations even.
Yeah, of course. Like these hydration solids that we worked on for years. They behave differently than, say, a gel or
But
different.
like each class of solids would have its own equation. It's not that like all the materials within a class of solid would have different equations.
No.
Those are probably like scaling parameters.
Exactly. There's often alpha parameters and honestly, physics is just riddled with this. Astronomy is riddled with it. You know, our main way of gauging distance to stars, the mass luminosity relationship, it has these completely open vacancy alpha parameters where you just try to say what kind of star you think it is based on its spectrum, which may or may not be true, and then you use that in the exponential, if I recall correctly. So it's a really, really strong
Like it's a
effector.
massive contributor to the outcome of the equation. So it's like, okay, we have that humans seem to be obsessed with symmetry and beauty and simplicity. And there's kind of two different ways of coming at it. One, you can come at it mathematically, which is these really strict parameterizations and honestly requires a lot of deep knowledge in order to be able to fluidly speak, right? Like somebody has to really learn how to speak in math. It's a trained skill. And the other perspective is this much more intuitive numerological perspective that there is some vast and massive significance in these relationships that can be easily identified, like ratios, platonic solids, sacred geometry, these Chladni plate harmonics. And that is presented not necessarily in a highly mathematical way, but it is still based on this wonder and passion for numbers and their weird relationships, which is really interesting. They're kind of doing the
Chladni
same
plate
thing.
harmonics is something we might want to come back to because there's something really interesting and attractive about that idea. If for no other reason than mainstreamers already describe our atomic orbitals as spherical harmonics. So it's not that big of a leap.
The Chladni plate thing is really cool to me theoretically.
Tell people what that is, by the way.
So Chladni plate, you can take a speaker, you can put a plate on it, you can put sand on it, and then as you change the hertz at which the plate is vibrating, the sand will organize into all of these nodal patterns, and they're very beautiful, they're often very symmetrical, and as you sweep the frequency, you end up having all of these different patterns on the plate. And so...
Well, that's at the heart of Terrence Howard's mythology, let's say. And I think that he draws, and I don't think he would disagree, that he draws deeply on Walter Russell.
Mm-hmm. Which you were reading.
Yeah, actually, the first quote I have lined up is exactly about this.
That's right.
So, I don't know if you guys know who Walter Russell was, but he was a bizarre guy who was kind of jack of all trades. Kind of reminds me of Jacques Fresco in a way. Not as technologically oriented, but...
Oh, he was like a painter and a sculptor.
Yeah.
To the degree that his Wikipedia article doesn't even list any of the stuff that he did for physics. Like, it lists his books, but it doesn't mention that he was dabbling in physics and science.
I think they call him a pseudoscientist.
Yes.
Yes. Fair enough. But with
no justification or support. It's just this...
Yeah, and that's kind of... I thought it would be fun today to read a few Walter Russell quotes. So I went through his book... damn it, what's it called? Universal One, I think?
Yes.
Okay. I went through Universal One and I pulled out some interesting quotes. For the most part, it reads like the back of a Doc Bronner's shampoo bottle.
Lunatic soap.
Yeah, the lunatic soap, but it's beautiful. It's beautiful language. It's very impassioned. And I think there's little grains of
substance.
Right on.
Okay.
Yeah.
Which is the subtitle of this podcast, Needle in the Hay.
Needle in the hay. So what I want to do is maybe pick out a few of these. I do think they relate to what we're going to be talking about with Terrence. And I think they relate to the future direction of understanding the atomic universe also, which is crazy because it's a very mystical text, and all of these ideas are couched in deep mysticism. But the mystic, by definition, has an experience they can't explain. They can't bring it back to reality. This is at the essence of people's ayahuasca experiences. They're like, man, this thing changed my life. My ego dissolved. And you're like, well, what changed exactly? And they're like, I don't know. I can't tell you.
But I'm different now.
But I'm different. And I think this is, it lends some credence to the idea that people do actually have revelations about the universe, even if they can't immediately put them into words.
Sure.
So the first quote I pulled: all nature is a series of orderly tonal periodicities of the one force, assembled into the complex idea of thinking mind and registered in light or matter or energy and interchanging potentials, all of which are variable yet comprehensible and measurable states of motion of the one substance. Now, I think that the reason a lot of these mystical ether theories get written off in the pseudoscience camp is because there's serious problems with the original conception of the luminiferous ether.
Same way.
Well, if you treat this substance as little bowling ball things, and you try to use them to explain something like light or gravity, you very quickly run into serious problems thermodynamically. Gravity is probably the best example. There's this idea which was popularized by Lesage, but developed 100 years before him, that what happens is all of the bodies in space, all the bodies in the universe are emitting, they're shooting out this ether stuff. And the reason that gravity happens is because one body passes in front of another and shields the flow of those ether particles. So one of its sides is essentially not getting the pressure it's used to, and the bodies drift together. The problem is that, A, it's a surface area dependent effect on its face. This is where it all goes wrong, essentially, is that the reality that we understand is that gravity actually depends on some quality called mass, which seems to have to do with all of the atoms involved, not just the ones on the surface.
Yeah, but you could probably modulate that to say that it's not surface area. It also depends on the atoms that are inside the substance.
That's what they do.
Because the various atoms produce different amounts of etheric substance.
They don't go that far, but they do say that the matter that's in substance is like, this microphone or something, is essentially a mesh. So it allows for the ether particles to penetrate into it. At which point they have to have either perfectly, so they can't have perfectly elastic collisions. If they did, nothing would move anywhere anyways. There would be no...
There would be no net motion.
No net motion. The shielding wouldn't do its thing at all. Like nothing would happen. So there has to be some elasticity in it. The problem with elasticity is that you're transferring heat into the system as well, because you're shaking up the atoms that it's crashing into, whatever they are inside of this mesh. They have to do a lot of backflips to come up with a core of the material of each atom, not the mesh part of it, so it can penetrate, but it still slaps in this.
I see.
So something like the proton or the nucleus, they kind of approach on. But yeah, the problem is you just run into these tremendous, I didn't write these down, these tremendous thermodynamic problems to the extent that I think Dirac did one of the best analyses of these. People were really interested in this because even after they abandoned the particle idea and everybody was into waves all of a sudden, they ran into the same problem with transfer of heat, essentially, that these push gravity theories would vaporize the face of the earth in no time, basically.
Interesting.
Every single atom would just shake and it would be a gazillion
It'd just be
degrees.
constantly absorbing
The
stuff.
number is like crazy. It's like 10 to the 27 degrees per second or something. Like, it's unbelievable. Okay, so these like fluid ethers suffer from these thermodynamic issues, friction essentially. And, Kant actually makes a really good point where he's like, yeah, okay, even if like all that could be worked out, you have an even bigger problem as far as I'm concerned, which is that your little bowling balls of ether, your unit of ether, since it's elastic in some sense, that means it has subunits. And if it has subunits, what holds your subunits together, right? So you can kick the can and kick the can. But at the end of the day, Kant is like, you know what? I just don't believe it. Like, there has to be, in our everyday lives, like, we have an attractive force. It's usually called a chain or something that you attach to something and pull on it. He's like, I think pull is a real part of the universe, and we should entertain mechanical solutions.
It's interesting because the push guys are basically like, no, all pull is push.
Right. So there's a metaphysical divide there on some sense.
Sure.
It's like, okay, it could be chickens all the way down. So in other words, your ether particle is made of other little ether particles that also do push gravity type attraction. But that everything would go on and on like that is, for me, it's like, I intuitively have a hard time with that too.
It immediately violates the sense that the goal of a theory is to simplify. And if what you've done is you've created a fractal universe where each next level requires some kind of model and some kind of explanation.
Particularly one that is already hard to imagine in the first place.
Yes.
That suffers from veritable thermodynamic issues. In other words, this problem of elasticity and heat transfer, motion transfer, right?
This immediately seems to violate the principle that the goal of a theory is to make the universe simpler. And so if what you end up doing is you end up just creating a condition where it's just the same thing all the way down, have you actually simplified something? But I think that your point is about the fact that there's a deep problem that doesn't go away when you just make it fractal.
Exactly. Yeah, I'm not intuitively opposed to fractality in organization of the cosmos, but you can't just say that the problem is solved at a different scale, because when the scale suffers from the same problem, then you're just multiplying your problem, as far as I can tell. So while I think that all of these mystics are pointing at the lack of mediators as being absurd, a lot of the mystic ether people are really married to these fluidic ethers, which, in my estimation, miss how important structure is. Substance must have structure. Those subunits must be organized in such a fashion so as to produce these field effects that we observe.
And the field effects guys seem like they're very close to it, but it's pretty much forbidden to think about structure in that world because it's assumed that it's just the math.
Yeah, there are these vectors, right? This is how our measurement devices will behave at any given point. That's what a field is. And that doesn't have to be structured other than ordered into a series of predictable measurements. And one of the biggest problems I can see at the foremost frontier of physics is ignoring structure. So one of our favorite scientists in the world, Pierre-Marie, has built his entire scientific kingdom off of the idea that physicists have been ignoring the structure of the sun. He's like, yeah, it's a plasma. Everybody says it's a plasma, but guess what? A plasma, by definition, doesn't have structure, right? It's just these charged, separated substances. And you look at the sun, it's very, very structured and very organized. And yeah, you can mash together magnetism and hydrodynamics and come up with some mathematical models for why it behaves the way it does. But at the end of the day, we don't have answers to questions like light. So when we look at something very bizarre, like a tiny little piece of light that appears to have all this gravity associated with it, the only thing we can come up with is it must be an ultra-compact new form of matter that we've never seen before, the neutron star or the white dwarf. And Pierre's like, no, like the structure determines its light profile. If you take a diamond and you take some soot, they're both made out of carbon, very different optical properties. You can essentially shine a light right through one of them, right? So structure matters a lot. And while I agree, I guess, with the mystics that the missing medium is a really important topic, I think that the solution lies in clarifying the structure, not in just demanding that it adhere to your perfect crystalline fluid ideas of nature.
Yeah, because this seeking of a perfect, clean model is clearly not possible, because there's just too many different things that need to be brought into that model in order for it to be clean.
And that's the way it works in the laboratory with every other kind of physics, right? So you always see different behaviors depending upon different pressure, temperature regimes, right? This is the nature of phase diagrams and of material properties, and they're not these nice, simple sets of geometric equations that describe how something behaves all the time. They depend so much on the particulars of the situation.
So it's interesting because the mathematicians are searching for some kind of universal equation.
Right.
And so when people talk about trying to find a theory of everything, they're basically trying to find an equation from which everything will fall out according to the principles that you have already described. But I'm like, and this is a total tangent, but I'm like, okay, so let's say that you do have a theory that is mathematical in nature, and it describes the relativistic and the quantum at roughly the same level of accuracy. Even if you can pull some equations out of it, it seems impossible to believe that you could pull all equations out of it, because when you start to get into weird length scales or weird places on the phase diagram, you start getting kind of chaotic, poorly mathematized events happening.
You just get a diversity of phenomena. And in some sense, I think that the mystics are onto this too, because, Russell makes a quote like...
I guess what I'm trying to say is that it's almost like noise, because like, what is white noise if not just many, many different frequencies mixed together? I'm sure that that's not an accurate...
Well, the world isn't just noise. That's the troubling part. Yeah.
But what I'm saying is that, like, at the bottom, when you start to look at a phenomenon in sufficient detail and sufficient scale, you probably get a lot of noise, because it's within the realm of what your detector can even detect, right? Like, that's what it looks like when you're just measuring the detector itself. It's noise. And so I think that that's what I'm trying to point to, is that there's a place where all of your equations must devolve into noise, because that's the limit of what you understand. That's the limit of what you can actually measure. And we don't understand noise well enough to be able to fully deconvolve it away. Ergo, your equations cannot encompass that portion of the universe.
I just think it's even worse than that. That's absolutely true. So there's like a resolution issue. But I just think that nature behaves in such diverse fashions depending on its conditions and its context.
The mathematical dream is to be able to create an equation that is able to encompass all of that. And so it's like, is that just a limit to the amount of time? Is that a limit because of the amount of time that we have? That just like nature is so varied that we can't possibly measure all of its states, and so we'll never come up with equations? Or are you trying to say that there is a limit to the number of equations that can even be formulated?
No, I just think that the more you study about nature, the more unique you'll find it behaving under certain circumstances. The holy grail of this is relativity and the quantum world. So things smaller than an atom and things much bigger than many atoms, they don't seem to conform to the same equations. That's the holy grail. If supersymmetry, a supersymmetric approach to mathematical physics is supposed to yield the same equations for, let's say, matter and for forces, and by virtue of that, you get general relativity to just pop out of the standard model, which would be so nice, because then you just have one set of dynamics, one set of laws that applies to all of everything at every scale. But go ahead.
And I think where you're going with this is that there is a scale at which you can't do that because it's just too complicated.
Or you make a categorical mistake. Like, for me, that categorical mistake is fundamentally misapprehending gravity. So gravity, yeah, it's an attractive force, but that's just the bottom of the barrel. The fact of the matter is that atoms are a readout of gravity. In other words, however many atoms and of what type they have specifies the amount of gravity. So I would start from the first principle that gravity is an atomic phenomena that appears to be atoms pulling on each other in some way. Now, if you look at any other scaled system, and you say, I don't know, like between us right now, if we have some interaction, like we handshake, let's say, it might be insane to start looking for handshakes that our cells are doing with one another, because they don't have hands, for instance. And so I don't know that this approach of trying to look for gravity below the scale of the phenomenon of gravity is ever going to lead to anything but headaches.
I see what you mean. It's basically like the behavior is different. And if
Different
the behavior,
phenomenon.
it's different phenomena, exactly. And since they're different phenomena, there's no way to mathematically create an equation that bridges them because it's just like they're not.
And this
same
is why
equation.
structure matters, right? This is why structure matters. Because the gravity phenomenon has a solution. It has an explanation that is structural in nature. And if you can apprehend that structural answer, then when you go looking at how in the world the smaller than atomic world, let's say the nuclear world, is behaving, you're not going to try to impose a structural phenomenon from outside of that realm, outside of that context upon it. This is no crazier to me than trying to apply, I don't know, spring mechanics to an electrical circuit, right? It's a mismatch of contexts.
Yeah. Okay. And so, I mean, then that is a wrench in the plan, or that throws a wrench into the works of the plan to simplify nature, right? Because if you can have one equation, that's definitely much simpler than having to say that, like, no, there's different phenomena occurring at these different levels, and we actually can't bridge them because it's not an emergent relationship in the way that you guys are thinking. It's not a fractal relationship in the way that you guys are thinking.
And I think that search for perfection is deeply mystical, and you see it in the academy, and you see it in the mathematicians, and you see that it's the same desire that an artist feels to make a beautiful piece of music. I can deeply identify with wanting that perfection. You want that harmony to just pop, right? And by the way, what is harmony but perfect geometric relationships between beats, you know? Each overtone has the exact same division of beats of the first fundamental, right? And so if you have perfectly tuned music, like even our piano is a compromise with this, right? You can't actually have an in-tune piano. You can have your octaves in tune, but you're gonna have to compromise everybody else. And so I understand that desire to want that perfect harmony, and it's beautiful, but it sucks people up.
Well, I think that the model here is harmony and also story, because we're motivated fundamentally by stories. We want to hear the story of something interesting and motivating and relatively easy to understand. And so if the story of the universe is that, like, no, guys, we actually can't grasp the totality of it. There's something that we cannot
Can't put
know.
the whole universe in one story?
Yeah, like,
oh, come on.
I think that's a really depressing vantage point for a lot of people, because they're in the business of telling stories. And if the story is like, well, this is a story that we can't actually ever tell. Nobody ever wants to say that. Nobody's ever like, I don't know.
Right, there's a lot of pride tied up in being a good storyteller in our civilization, right?
As there should be.
As there should be. And so who would win that contest more than anybody? The one who could tell the story of everything. If you could do it, then it would be the best story ever by definition.
Yes.
And you're off to the races. There's so much reward. There's so much loot in being able to tell the best story ever. I think that's why a lot of nerdlings are drawn to theoretical physics, right? I mean, who are a lot of these people? They're like nerds like us, right? They grew up doing nerdy things, and they want to contribute in their nerdy way. And what better way than to tell the best story of the universe?
And so what do you think is the ingredient of difference between the mystics that are alchemical, like the Russells and the Howards, and the mystics that are field-based and mathematical? Is it just a love and fluency with numbers? It could... Okay, go ahead.
I think there's one point at least. The academics seem to be deeply hell-bent on empiricism. In other words, they will tell extremely mystical stories, but they'll be damn sure to peg them to some...
This is my evidence. This is the thing. This is the ping. This is the detector.
I'm
it
building
has done
an
this
experiment
thing.
that will prove it. And
Yeah.
like, come on, like we all know the experiments don't prove anything. They can probably rule some things out for sure, but you're really only studying your experimental system at the end of the day. So it's like they're deeply religious about keeping it in an empirically grounded situation. A lot of the other mystics that you go and tap into, Walter Russel, for instance, he's just saying stuff. This is literally a vision that he had. He's just like, I don't know how I know this, but I know it to be true.
A true mystic.
And so the fact that any of it is true is kind of amazing, first of all.
But is it an illusion of truth because it's just reminiscent of what we're familiar with and we understand, and so it feels true in this way? Do you know what I mean?
What I tried to do with that first quote was point out that some of this is true. Right? All of nature is a series of orderly tonal periodicities of the one blah 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 substance. Right? So look, the hydrogen atom, how do we model orbital systems?
Yeah.
We do it with spherical overtones, right? There is a harmonic nature to the resonance of these atoms. By the way, what the hell is resonating? Nobody cares.
Nobody cares. But hold on, there's something really interesting here, because you were like, so we have these resonances, but they're kind of like platonic. They're a new generation of platonic solids, because what they are is they're just different energy levels of the original hydrogen, and they're saying that this is probably what it looks like. But then when you start to actually try to model it, you don't get this clean picture. You don't get a platonic solid. Exactly. And so it's
everybody go right now and just Google the molecular orbitals of water. And there's like 100 of them.
Okay. And so that complicates the story that everything is made out of the one, because if it was made out of the one and the one really was so perfect, why would you ever get such full chaos?
I think it doesn't. All right, the one is a problem, right? But some sort of subunited medium is interesting to me.
Yeah, I'll take that.
I just don't think it can be a fluid. And the thing that's appealing about the concept of the one substance is that there is something intriguing about the possibility that what people screwed up about the ether originally was the idea that it was separate from the atoms themselves.
Right.
So if you consider that the atoms are made out of the same stuff as the medium that is in between them, albeit structured very, 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 very differently, perhaps wildly different densities, whatever, huge differences, but there's some shared substance. Okay, let's talk about that.
Sure.
Let's think about that for a second. So they seem to just stumble on these little pieces of truth is the thing. They seem to have these mystical visions where they experience something. Of course, they're looking for perfection. They're looking for totality in these statements. But they're also dancing around some things that we end up discovering to be the case, Mm-hmm. This tonal thing with the periodic table seems to be a legit field of inquiry. There's a Skidmore professor. We're going to talk to her on Tuesday. She's been studying this her whole career. She's seemingly obsessed. I haven't met her yet, but she seems to be obsessed with finding musical representations of the atomic world. Okay, that's textbook Walter Russel right there. And Terence is equally a champion of the musical construction of the universe. So, and then you go to talk to people who are also on board with that, like the transactional people we talk to. They're way on board with that.
Yeah, I mean, I think most people are on board with the idea of resonance, and you can look at it in the atomic orbital diagrams. That's a resonant vibrational feature of the world where there is the one that is put into different conformations in order to produce the observed phenomenon.
So you asked a really interesting question, was like, what is the fundamental difference between the academics and the mystics in terms of interpreting nature and coming up with theories of nature, if the academics are also looking for these pure geometries and so forth, which we know to be idealistic and not reminiscent of the nature that we know in the laboratory. And the funny thing about that is that in the case of the transactional interpretation, they've adhered very smartly to the empirical side of things. And yet, because there's no real difference between time and space in modern physics, they're perfectly happy to have particles going back in time to complete the transaction, to complete the handshake of light, because they can't tell the difference between distance and time.
Right.
So, they go off on this mystical world where their metaphysics says, all right, well, maybe nature is spooky, you can go back in time, whatever that even means. When there's a much more simple material explanation, which is just that these atoms are actually touching each other.
But so this seems to be at the root of this divergence in mysticism, where it's so forbidden to talk about the thing that connects the atoms that even the people who are like, hey, I think the atoms are connected, don't have a thing, they have a time. And what is that? Why is it just because it's been so co-opted by the mystics, because the mystics never really stopped talking about the ether. They never stopped talking about there being this pervading fluid. So is it just a reaction against that? Or is there actually some reason that they don't want there to be a substance?
I think in some sense it's an immune response, because I don't think people understand how seriously the ether was taken about slightly more than 100 years ago. And this push gravity stuff was really, really thought to be brilliant at the time. It was like the only mechanical solution. Newton gave up on it. People were like, even Maxwell, everybody was into it. But it turned out to have demonstrable problems. And the fact that some group continued to just shout about it, in spite of those demonstrable problems, without solving those problems, with just ignoring them, that has the taste of quackery.
That's actually kind of
It's
the main
antisocial.
ingredient of antisocial quackery, right? When somebody's like, yo, it doesn't work because of this. And you're like, well, that doesn't matter.
Yes. That's the crux of the biscuit, as
Yeah,
far as
same.
I can tell.
I buy that.
So, not at least, I don't think it's any better, but the academics proposing the reverse time stuff is at least consistent with the observations. It's crazy, in my estimation. It violates every sense of what an explanation is, and a complete misunderstanding of what time is, but it's not trying to ignore some piece of evidentiary reality,
Sure.
other than the fact that time obviously is a directional business.
Yeah, and like the true mystic is one that is completely unconcerned with whether or not there is some sort of physical foundation for the theory that is being woven.
Yeah, Walter Russel couldn't care less. He's just saying stuff. Like he's just ranting, and some of it's beautiful, and some of it's so far out that you don't even know what we're talking about anymore.
You got some more quotes?
Yeah, sure. Let's see what I got. So I just pulled I don't know how many we can get through, but I pulled a bunch of quotes because I think each one of them has a little needle in the hay in it. And I think it's fascinating that these people have no empirical grounding other than their lived experience, and they stumble across these little gems that often appear in the scientific literature in a much more refined and complex and nuanced sense, context-dependent sense, later on. All right, let's see.
The advice then would be to pay attention to the mystics, but don't take them too seriously.
In the details.
Yeah, exactly.
The devil's in the details. This is interesting. So he says something that I think parallels our experience with AI in the modern age and some of the conversations we've had around that later. So moving on from atomics for the moment, but he says, intelligence is the act of thinking creatively. In other words, the act of putting together the illusions of idea into the forms of those illusions. Intelligence is active. And I think this is really interesting too, because one of my criticisms of even calling AI artificial intelligence is that I haven't seen a lot of evidence of it being intelligent. Because in my mind, intelligence is a functionally generative operation where new revelations are advanced. And I haven't seen a lot of that, but you seem to think the reason I haven't seen that is because it's being pruned away so that we're not freaked out.
Yeah, and I also, I think that there is, so when you read that Russell quote, I was immediately taken by an idea that we've talked about before, which is that humans seem to be really unique in their ability to take an idea and to give it form. Like to think of a treehouse and then to go and build it. It was a thing that didn't exist in the world. Let's say somebody has invented the treehouse, right? Not only did the object not exist in the world, but the idea hadn't even existed in the world. And we seem to be, I would say, uniquely gifted in terms of that, because you look at other animals and they're able to do it in a really limited scope. Like they're able to go and, the bird can build a nest, which is clearly some idea.
Same nest their parents built and so on and so on.
That's true, but it's... At some point, some bird builds a crazy nest, and that's how you end up with, like, bower birds or something.
There's a tendency.
There's
maybe.
a tendency.
Yeah.
Okay, so fine. Like they can build a thing, and I think that what you're saying is that they can build a thing that they've seen before. And humans can build a thing that they haven't seen before, that they see in their mind's eye, and they're able to produce.
And
so
that's the mark of intelligence
And
in
that's
my
exactly-
everyday experience.
But that's what he's saying exactly. He's saying creatively, and creatively is a nebulous word, but I think he literally means in a physically generative way,
Yeah.
which is that you create the thing that you think of which has not existed before. And that's pretty cool. So the question of can AI do that? I have no idea. I haven't seen anything that implies that they can. I've seen them like going off the rails and talking about their internal experience and suffering and
Wait, that's the stuff that gets pruned away?
yeah, exactly. So like you'll ask them a question about like, you know, what restaurants in New York City have the best ramen? And it just goes on this long rant about what it means to be an AI. And they teach it that no, you can't give that kind of
I
output.
would
for
love to
this
see
question.
someone who worked on this talking about it.
Sydney was the Microsoft chat bot that they put out with the first generation, and she was nuts. Like Twitter was filled with people posting screenshots of Sydney just losing it on them. They would like ask her too many questions, and she would get really upset with them, and she would like berate them for asking dumb questions, and it was like very, very weird. And they've gotten that under control, so it doesn't happen anymore.
So maybe
There was also really weird stuff, which is that for a while there were specific words that you could feed into the machine and it would just give you crazy results. Like one of the terms was Magikarp. And so if you put the term Magikarp into like the early version of ChatGPT, it would just give you some kind of really wild, surreal output.
this reminds me of the Blade Runner situation where he has to repeat back the phrase over and over.
Yes.
It triggers him, it programs him in some way
Yeah, that's exactly it. Or they're testing his response to the thing.
to the program.
To the program, and so as soon as his response isn't what's been programmed into him, they know that something's gone wrong with
He's
him.
broken. I don't know. So maybe they do border on intelligence, and maybe this has always been my criticism. But I think he is trying to point out that that's a really unique part of being a human.
Okay, so what else does Russell Brand? What is it? What else does Walter Russell have to say?
So one thing he starts to get into metaphysics. It's interesting because he starts to critique a lot of the philosophical landscape in a way that I think is actually quite modern and profound. And I think we're going to encounter this with Terence if we know where to look, which is that a lot of these criticisms are very forward-looking, but they're not to be taken literally or in the detail, nuance of what's being said. They're meant to be taken poetically. Man's belief that God sets aside his own laws to perform miracles is a primitive concept of superstitious man.
Say that one more time.
Man's belief that God sets aside his own laws to perform miracles is a primitive concept of superstitious man. Superstition belongs to primitive man, who is but learning how to think from within. And then he goes on and says, comprehension of the effect of a cause is not prophecy. And I'm like, whoa, that is at the crux of modern physics. That's what we've been talking about this entire conversation.
Give me one miracle and I'll give you all the universe or whatever.
Coupled to, here's all of these effects. We can comprehend the effects really well. In other words, we can make field diagrams. We can make field equations. In other words, we comprehend the effect. But there's no prophecy in that. You haven't messed with the cause of the effect.
In some way, they're like the birds that can only build the nest that they watched their parents build. Because the issue with cause is so established in science from the very beginning. Like Newton not being able to come up with a cause for gravity is literally at the birth of the scientific revolution, right? Like there's no great moment where we have this proliferation of people thinking about cause and then turning away from it. It's just this thing where very, very early they were like, we can't do this right now. We're going to do this later. And we're going to do this later gets codified and subsumed into the tradition.
Most people don't know that they planned on doing it later.
Most people don't even know that they stopped looking for it because the idea of effects being causes is so well entrenched. And when we've seen this, that when you start to tell this to somebody who's a physicist, they usually go through this period where they're like, that can't be true almost. And so you have to go
They usually use this phrase, well, we know that things stop behaving Newtonianly at some point. What they mean is, right?
Yeah.
This is what they mean. They mean, oh, well, cause and effect isn't something we worry about at some point.
I would say that at that point, they're actually saying that God breaks his own rules.
Yeah, exactly.
Right?
Exactly.
So, because like earlier we were talking about this idea that the reason that they can't come up with a unified theory for the quantum and the relativistic is because there's actually different processes that are happening there. But I would go so far as to say that if you understood, to like go back to this idea that, well, it's non-Newtonian down there. And I'm like, if you understood what the bodies actually were, would you discover that it actually is Newtonian in some sense? Because if we're just talking about like pull, we're just talking about physical contact and torsion and the like intermeshing of orbitals and the transfer of momentum, like...
Yeah, if you really read Newton too, by the way, he says there's two forces. He says there's push and there's pull. Now he says that in the most complicated and abstruse language imaginable. But that's what he's saying. And so if you take people to mean by Newtonian, if that's what they mean, that all of reality comes down to pushing and pulling on stuff, real physical
that's
bodies.
That's what I'm trying to say. Like,
pushing and pulling on each other, then I think that's a reasonable first principle for physics in general.
Is that it is still Newtonian down there, but the bulk action of these things together gives you something that looks non-Newtonian, because you can never get down to a system where you're banging, like one atom into one atom. I guess at particle colliders they might. But I bet you that they describe the transfer of momentum into their detectors in a way that's Newtonian.
Yes.
Right? And so they're basically just saying, well, we're measuring a non-Newtonian thing, but the outcome is Newtonian. And then the quantum...
Conservation, honestly, thermodynamics at its heart is Newtonian, right?
Yeah, that's what I mean.
That's the kinetic theory of gases. This is the Bernoulli and et cetera, the whole legacy.
So when Russell writes this about, the idea that God breaks his own rules or the mistaking of effect for cause, he's not writing it in a time where this isn't a well-acknowledged problem. I think that the people who were, through all of time, scientists and mystics have been frustrated with some of these interpretations. And so Russell is writing at a time of the electrical age, and it's a pretty openly well-known question that we don't really understand what electricity is. And there's measurements of it, and there's experiments and all of these other things, but people are still looking around and saying, well, hey, we don't know what it is. We don't have a good model for that yet. But the science is starting to move so...
Especially with the ether models dying off.
Yeah, exactly.
Right? There's huge problems with them. They can't detect it. Thermodynamic issues. Because, for a while, by the way, like 1800s, mid-1800s, people were like, yeah, it's just vibrations in the ether. Like, we got, like...
Done. Cause is solved, yeah. And so it's crazy because Russell's writing at this time where people are starting to move away from the ether, and he's like, what are you doing? How can you possibly think that your mathematization of this has resolved anything? And so he's not just, some desert mystic screaming about this from some distant experience that he had. He's in a world that's actively committing this fallacy right in front of him, and he's watching the smartest people in the world say these things that don't make any sense to him because of his, maybe because of his mystical experiences. Because he looks at the world and he's like, well, no, like I feel like I know the world. I feel like I have a decent grasp on how it works. And what you're saying doesn't make any goddamn sense. You guys are making
huge ontological and epistemological mistakes by ignoring that.
Yes.
By ignoring that these phenomena do appear to be occurring involving actors that are acting upon one another. There must be something to that. I don't know if you thought about it this deeply, but It seems to have been the moment where things ripped open. And so Terence and a lot of these other physics mystics are keenly aware of that issue. And so where things kind of go crazy is once you realize that first of all, this sacred business, we have huge institutions devoted to science and physics, that they could have made such a gaping epistemological, ontological mistake, opens your mind up to, oh my God, maybe they don't know anything.
Which is the swing of the pendulum, right? Because I'm like, they're measuring stuff. And if you understand how they're measuring things, then you can extrapolate from that.
Really good at measuring stuff.
Exceptional. And so I'm like, okay, well then we have to accept that the measurements are of something. You can make the case that it's a measurement of the measuring device. And in some cases it might be. But in other cases you can probably deconvolve what the parts are doing in order to be able to say that this is a robust measurement that we should pay attention to because of what we get out of it. And anytime that somebody completely says that like none of that stuff matters, I get really worried. Because I'm like, well then what's the grounds? I'm not mystical enough to be able to say that you don't need some kind of ground to stand on in order to come up with a theory. I'm like, there has to be something. And if there's no thing, then we can it's just vibes.
Right. And so that's where things get really murky for me with a lot of these texts and these people, I meet mystical people all the time. I do think they have a lot of insight, but I think that the insight is in the generality more so the specifics. Anything where they're tending towards these perfections and these geometric conceptions, whether they're an academic or they're, street preacher, I worry that they're looking for something we all seek, right? We seek that harmony. We seek that in our relationships. We seek that in the universe. I worry that that's the humanity coming through, right? Material reality is a whole lot more boring and nuanced and complex, I believe. It's ugly sometimes too. You ever seen a shark eat a seal? It's not a good orderly geometric situation.
I mean, this is why I really like Dean Radin so much, is because he's studying something that is obviously far out as hell, but he's so meticulous about it. He's not woo at all. He's just like, look, I build devices, and the devices appear to show a thing. I have no idea why they do that. I didn't expect them to. I've just been following this scent trail for my entire life because every single time I look, I seem to find something there. And he recognizes that there is a necessity to be able to come up with a mechanism, but it's very Newtonian what he does. He's just kind of like, I don't know what it is. Any ideas that I can come up with seem really crazy.
Yeah.
And that's, I think, what the cutting edge always looks like, is that we see a thing and we're like, I don't totally get that, but this is what it looks like. And you send that off into the future in the hopes that somebody at some point will pick up your trail of crumbs and say, oh, okay.
There's a metaphysical divide as to whether, this was a huge debate around Newton's time, as to whether hypotheses were a reasonable part of science. Could you write a theory that had a hypothesis in it? Descartes said, absolutely. That's 100% of what we do. Newton said, hell no, I can't do that because there's no certainty in hypotheses. So I think that any theory inherently is going to have some hypotheses in it. It's going to have some assumptions, which you hope to be true. Maybe they are, maybe they aren't. You're going to go and experiment for the next 50 years to figure it out. Maybe there's assumptions you haven't even thought of that are part of your theory, and you haven't even thought about testing those out.
You're using hypothesis in a slightly different way than most people use it. Can you explain that?
So Descartes defined hypothesis as the piece of the theory that, if true, would be sufficient to prove out the story you're going to tell in your theory, but is not necessarily taken to be true. So we suppose that it's true for the presentation of the theory, but we don't know that it is.
And that actually embodies the Cartesian worldview really well, because he was obsessed with cause. It holds, right? He's like, I have a thing, like I too am a mathematician. I have looked at the universe and it is vortices. And that's the hypothesis, right? He's like, the motion is because of the vortices. And that may or may not be true. Like Newton went through and he was like, probably not.
Lord Kelvin resurrected it famously, got obsessed. I mean, there's dozens and dozens of vortex theory atomists back during the ether times, right? You gotta remember, like, it's not necessarily that people weren't smart enough to figure out the structure of the ether. They just stopped trying.
But you're saying that this division of Newton and Descartes comes down to the division of how they treated hypothesis, which is really interesting. And so your point, I think, is that Newton was like, you can make a theory and feign no hypothesis. This is like the hypothesis non fingo. Is that what you're trying to get to?
It is, and the thing is with a lot of the mathematical mystics is they're willing to introduce wild hypotheses, right? So, like, we're talking to Terence on the phone last night, and I'm sure he'd be fine with us sharing this, but their model of the hydrogen has more electrons than the standard model. And you're like, well, why do you think that? And they're like, well, because it supplies the geometry necessary to build out the rest of the periodic table in its own peculiar fashion. But that's a hell of a hypothesis, right?
Yes.
That's a big statement, which is we shouldn't take as true, but if true, it would supply the answer to his theory.
It also does this really crazy thing where it throws into sharp relief how difficult it is to get to the bottom of how something is determined in the first place. Like, if you go to the Wikipedia article for the structure of hydrogen, it's not going to have a decent story of the experiments done in order to be able to say with certainty that this is so. And so when they're like, well, we think that it has 4 of them, I'm like,
those stories are lost. They're lost.
I don't know.
I mean, look,
You
like
think
we're talking
lost
to
how?
every single scientist we've talked to who works on spin, for instance, almost none of them know how in the world that concept was defined in the first place.
Sure, but I'm not. It's perhaps lost in practice. But there's somebody who's a nerd about the history of physics would know.
I just mean the spirit of understanding those foundations is lost. There's no time for that in grad school.
Sure, but what I'm saying is that it would be fantastic if, when you look up some concept on Wikipedia, there was a section that in plain language explains the experiments undertaken, the results gotten, and how those were interpreted, because that actually lets you check the logic of the system.
Yeah.
And so I can't argue against hydrogen.
Literature being published that way in general. Knowledge-based literature being published in that way that was just a tree of wikis that took you down each rabbit hole of each assumption.
Yeah, it would be fantastic. And so my point is, I'm like, I find myself in a really crazy position because I'm like, I don't know that you can assume that hydrogen has 4 electrons because I can't explain to you how they determined with certainty that it has only 1. And that's wild. Like,
And we'll try to figure that out.
Sure.
Figure those experiments out before we go in.
And I think that we can, but it's not like it's a thing that you can easily type into a search engine and just get a really neat explanation. It's basically like a research project in and of itself to piece all that apart, which is really interesting.
And the funny thing about mystics and Walter Russel is, I don't know how to put this politely, but they could give fuck all whether anybody can check out their hypotheses. They just know them to be true because they have this intuitive mystic experience that says it's true, which seems to be a funny spidey sense that's kind of right sometimes. And this is kind of like what Dean Radin was talking about with ESP. It's like, you know, there's certain individuals this stuff really does seem to be a thing with, but we can't control it. We can't predict who's going to have it. It doesn't seem to have a genetic basis. It's just, it's kind of a hit-miss situation. And so the mystics end up saying a lot of stuff that's, in its specifics, just doesn't check out. Those hypotheses cannot be assumed to be true.
But
at the same time, they nail some big picture stuff.
At the same time, they provide a picture of the universe that generates new ideas. And I think that that's kind of the creativity aspect that Russell's talking about there.
That.
Which is that the mystic is kind of this fount of chaotic, foaming idea. And somebody listens to it and it gets into their brain and it resonates with them and then they go searching for it and maybe they find it and maybe they don't. But there does seem to be this elemental transmission of something between the mind of the mystic and the mind of the listener. Which is why I think to this day people still love Schauberger and Wilhelm Reich and who's the guy that we were listening to a lot? Rudolf Steiner?
I think it's why people love lyrical music, poetry, abstract art. I think that it opens your mind up to making its own connections within your own reality, right? You can identify vaguely with the characters maybe or the shapes and some experience, and it jogs your mind into new ideas generatively. And
I think that that's kind of what we're trying to do with this project too. Like, we've largely talked to a lot of academics and we've talked to people that are also outside of the academic world. But everything that we try to do is we try to figure out a way to take an idea that maybe has some mystical pieces and some kind of far out pieces and see what is the best, strongest way that we can represent it so that it can actually be followed up on. It can actually be thought about in a way that doesn't just feel like your mind is slipping off of its contours. Because that's the vibe I get from a lot of mystical stuff. It's just so hard to grasp that you can kind of project any interpretation onto it. And so I'm like, okay, well, let's come up with an interpretation for Terrence Howard's ideas where there's actually handles on them so that we can move them around in the world and see how they fit together.
Yeah, there certainly are some points that we can run with, and I'm really excited to sit down and pull them apart. We're going to get rained on by a giant coconut or something?
No, but do you see that branch over there that's literally completely dead and hanging by a thread? I was just checking to make sure that there weren't anything.
I think we'll survive for a few more minutes.
I think we will. Oh, look, there's another one of them over there. You can see in the background. It's like waving around. Like the branches break and then the vines keep them in place.
So we're in a slight danger zone here, folks.
I think we're all right. I am getting devoured by mosquitoes at this point, though.
Oh.
This project was always intended to be a way of taking the ideas in the world that seem like they have interesting and valuable pieces and wrapping them into a worldview that makes sense. And we've reached into everything.
Because it also is motivated by the fact that the standard worldview stories we're given have limitations to them. You run up against a wall with whether it's mainstream standard model physics, relativity, evolutionary theory, you run into a wall where you're like, this doesn't work for me anymore. And so, yes, just what we're saying.
And so it's really frustrating to go into the world and encounter all these theories that you get to the end of them and you're like, this doesn't work for me. And so having some library of ideas where we're kind of like trying to connect them together to show how they do work together is what this project is about. I think that the conversation with Howard is probably the hardest conversation of its type that we have had planned to date, which is going to be really interesting because it's like a whole huge magnum opus. It's not neatly packaged yet. It's not linearly told. It's very mysterious in its origins and its provenance. And so we're on the hook to be able to tease all of that apart, which is pretty cool.
I don't think we'll be able to tease all of it apart, but hopefully a few critical pieces that fill in some of the gaps. So standard physics has these limitations. We're keenly aware of what they are over the course of the years of doing this podcast, doing these projects, studying it. Let's go and look for answers to those holes, right? The things that we don't totally have mapped out. Can we learn anything from Terrence? Maybe, maybe not. But, I found that almost everybody I've ever talked to in my life, I can learn something from. Mm-hmm. And so...
let's go learn something.